Hello students. In today's slide, we will be discussing about switched mode power supply, that is SMPS. The switched mode power supply is an electronic circuit which converts the power using switching devices that are turned on and off at high frequencies, and the storage components such as indicators or capacitors to the supply power when the switching device is in its non-conducting state. It can be also called SMPS. The switched mode power supply is also called switched mode power supply or switching mode power supply. It is its efficiency is high. That's why we use it in variety of electronic types of equipment which require a stable and efficient power supply. We can classify switched mode power supply by the type of the input and output voltages. This is the block diagram, a simple block diagram that how the SMPS works. So let's see here. Before starting the working principle, we will first see what are the components. Here we have input rectifier and filter, we have inverter or chopper, we have output transformer, and we have a output rectifier and filter. Okay, so first at the beginning part, we have main input, that is the AC input. Okay, so and here you can see at the output part, we can see we have the DC output, right? So main work of SMPS is there is a input of AC, and in form of that either there is a input of AC or unregulated DC, which is later on converted to the regulated DC output. Okay, so at the very first step, the mains input is the AC input, which is further rectified to DC using the input rectifier. So if we are not using the AC current directly, we are getting the DC current, then we don't need this rectifier part. The rectifier, the DC current is at the next step also filtered, and the DC current is filtered, but still the DC current is unregulated. Okay, so here we have a inverter. The work of inverter or chopper is to chop the DC current into high frequency and convert it to again AC current. So here the inverter is to convert the DC to AC current, and the chopper is to chop the DC current into high frequency so that the voltage in the unregulated DC, we get a very high voltage of DC current, but after converted into AC by using inverter and chopper, it is given high frequency in which it pulls down the voltage, so the voltage becomes low. Okay, now we have the output transformer. Here the output transformer also brings down the voltage to a stable level. Okay, and at the stable level we get a regulated AC output. After getting a regulated AC output, we all in all need our output as the regulated DC output. So at the last point we use a rectifier and a filter to get a required DC output, regulated DC output. So here the transformer is to check the high voltages or to get the required voltages, and we get a stable output. At the other part, we have a chopper controller, or we can say this is the feedback circuit. If within this main stream there is any kind of problem or we need any kind of changes, then the chopper controller manages this all changes. So we will go further and see the working principle of the SMPS. The working of basic AC or DC, the working of SMPS is to convert AC or DC to regulated DC. Okay, so for this we first of all need input rectifier stage. We make use of the stage to convert AC into DC, and the circuit which has DC input does not require this stage. In this, the rectifier produces unregulated DC. We pass this unregulated DC through the filter. Next, we have inverter chopper stage. This stage converted DC. In this stage, the converted DC is chopped into high frequency by running it through a high power oscillator. The DC supply can come either directly from the input or from the rectifier stage. The output of the power oscillator converts fixed DC to variable DC, converting it into high frequency DC. Through the inverter, it is converted to AC. Output transformer. If we want to isolate the output from the input, the inverted AC is used to draw the primary winding of the high frequency transformer. It converts the voltage up or down to the required output level on its secondary winding. The output rectifier. If we want the DC output, then the AC output from the transformer is rectified and the filter removes the harmonics and repulses and provide us the regulated DC output. The a regulator or chopper controller, or we can say it as feedback sensor. In this, the output voltage is monitored by the feedback circuit and then compares it with the reference voltage and is further rectified. So these are the whole transformation steps from AC or DC to a regulated DC. Here we can see a neat and clean diagram of the working of the SMPS. This is the SMPS block diagram in which we can clearly see that the input AC supply is given, which is of standard low frequency. So low frequency means it is high voltage AC. Then we use a rectifier here. The use of rectifier is to convert AC into high voltage unfiltered DC. So here we use a filter. Next we use a filter so that we get the unfiltered DC filtered. So finally we get a high voltage filtered DC. Next, what we need to do? Next work is of the chopper. Here the chopper is used to chopper and the inverter, which works two things, that is the DC is converted to AC and the high frequency is given, and finally we get the high voltage AC. Okay, so this high voltage AC uses a transformer or chopper so that by giving it more high frequency, the work of chopper is to increase the frequency. Okay, when the frequency was low, the voltage was high, but here the chopper and the work of transformer is to give high frequency so that it lowers down the voltage. Okay, so finally, by using the transformer and the chopper, we give higher frequency and low down the voltage AC. Okay, so next, at the next step, we use a rectifier and filter. So we already know the rectifier is to convert the low voltage AC to low voltage unfiltered DC, and the filter is finally used to convert the unfiltered DC to low voltage filtered DC, that is regulated DC, and that is our final output. Okay, regulated DC supply. Besides that, we have a feedback sensor or feedback transformer, which all in all checks or keeps a feedback of if there is any error detection while this process, and it is the controller circuit which controls the any changes by pulse generator or oscillator. So this feedback circuit is a sensor which senses any trouble going through the SMPS. This is the all in all block diagram and functioning of SMPS. Now we will go through some of the applications of switched mode power supply. The first application is it is used in machine tool industries. It is used for security systems. It is used in personal computers. It is used in closed circuit cameras. It is used in mobile phone chargers. It is used to support supplies with PLCs. Besides that, there are some of the advantages of SMPS too. So, at the very first point, it is very efficient. In this, little energy or the energy consumption is very low, and the heat generation is also very less. That is why its efficiency is high, which is from 68% to 90%. Next advantage is it is compact. The size of switched mode power supply is very small, so that they can be transferred from one place to another very easily. Next is flexible technology. We can use this technology very easily. We can make use of this very conveniently. So this is all about SMPS, its working principle, its advantages and applications. So this is the end to this chapter. Thank you everyone.